I want to start a series focused on cybersecurity. So I figured I'd go over a program that I wrote. When did I write it? 2 years ago? 2 years ago. I believe I wrote it 2 years ago, and then I made some edits this past year. But basically, it's a hash cracker. So I'm going to go through what that means. But I feel like this would be a good introduction to the series. I recorded a 55-minute video on how to install Kali Linux if we end up using Kali Linux during this series. But unfortunately, it failed at the end, and I just won't even bother. So I'll do that in the future, but right now, this is what we're going to be doing. Okay, so before I actually get into this program, I want to say a couple of things that are super duper important. This was 100% intended for educational purposes, and in no way can this be used for anything illegal and or unethical. This is a program to learn how hashes work, not to crack passwords that you don't have permission to crack. I really cannot stress that enough. When we start getting into more cybersecurity focused videos, I'll have a disclaimer like this in every single one, but this is for educational purposes. This is so that you educate yourself, you learn more about computers, programming, cybersecurity, how passwords are stored, stuff like that, okay? I'm educating you so you can be a good guy, you can strengthen security in the future and not break it down, right? So once again, just quick overview. I cannot stress this enough. This is for educational purposes only. That being said, let's get into the video. Sorry about the seriousness, but this is a very serious topic. So let's jump right in. So if you don't know, basically this is how passwords are saved. So say I go to a site and it asks for my password, right? So it's like type in your password here and you type it in. Say my password is, we'll go really simple, right? Password. Do not use this password ever. I'm sure you all know that if you're watching this video. But let's say my password is password. If the site was to store the password as password, so rather when it says like Matt Scripps, sorry for my typing, and then it just stored password, that's a serious problem, right? Because say they ever got hacked, then all of the passwords would be in clear text, right? So then basically the way the logins would work then is you just have an if statement that would say like, if saved password is equal to, of course this isn't real code, but is equal to entered password, right? And then, it would log you in if that came out true. So since that's not the case, and it would be very dangerous to actually save the password in clear text, what sites do is they hash it. So a hash is, what even is a hash? Am I qualified? No, so a hash is basically a string of text that is unique to the entered information. So if I type in password and I hash it, I will get a specific output that I should not get with any other input. So if I type in password 1, I'll get something completely different. I can even hash an entire document. So if you've ever gone to like download a program, and the funny thing is I'm gesturing with my hands, but I don't have a camera. So just pretend like I'm moving my hands around. But basically, say you're going to download some software, you might see like a hash document. Let me actually pull up an example. Okay, so here's my example. Basically, this is the operating system for Raspberry Pi, or one of them. So it's the Raspbian OS. So say you came here to download it. So if we wanted this one and we wanted to download it, then it's giving us here SHA-256. So that's a hash. So basically what they did was they downloaded the zip file and they hashed it, and this was the hash that came out, okay? So say I download this and I don't get this hash, so I'll show you what will happen. So let's go into my downloads folder and let's run SHA-256 sum. This means calculate the SHA-256 of whatever file or text I'm giving it. So I'm gonna give it 2020, this one right here, that's the file we just downloaded, and we should get this exact string that's right here. So it's gonna run this. It does take a second, but you can see right here, look at that. So if you actually went through all of this, this is gonna be the exact same string as is right here, okay? So if you see my mouse, that's gonna be the same. That means that this is the exact same file with 0 exceptions to the one that I just downloaded from here. So that means the one that they're storing on the server is the same as I downloaded here, right? So that's just my example of uses for hashes outside of passwords. But now let's get into how this works. That was useless information. I might cut that out. All right, so let's take a look at this program. So once again, this is the project. Basically what it's meant to do is crack hashes. So of course, if you have something like encryption and decryption, I'm sure you've heard these words before. It's not similar to that, but it is similar in the case that it changes the output. So let me give you a quick example. So if I do echo hello, it'll print hello to the terminal. If I do echo-n, because the issue with that is there's a trailing new line, you'll see it won't go to the next line. So that means that's actually how we're going to print that. And we're going to pipe to MD5 sum. MD5 is a hashing algorithm, and you'll see we get this output right here, okay? If we change one thing about this, I'm going to make a lowercase h instead, the hash will be completely different, okay? So that's basically how the passwords work, right? So it'll store, say my password's hello, it'll store this text, and then if I enter some other guess, let's say I enter the right guess, you'll see it'll be exactly the same, and it'll let me in. If it's different, say I had a 1 at the end, or even if I just typed in password, right? It would be completely different, it wouldn't be the same, it wouldn't let me in. So that's basically the gist of how that works. The issue is, or rather, the feature is, you can't actually decrypt these. Because of the way that they're set up, you can't go from a hash to a password or to a file. So to crack these hashes, what you actually have to do is you have to compare a hash to a hash. So that means, say you have only this text here. So you know this text, you don't know anything else, you have to get the password that's associated with it. What you do is you go through a big word list, and say this word list has 14 million words in it, okay? 14 million possible passwords. What it will do is it will go through each of those passwords and say the first line is 1, 2, 3, 4, 5, 6, and it'll look at this hash, so it'll hash that, and if they're equal, then it knows the password is 1, 2, 3, 4, 5, 6. So basically that's what my program does. Let's take a look at it. Okay, so really the only file here is hashcracker. So we're gonna open up the code, I'm gonna give a quick overview, and then we're gonna run it. So let me open this up in Atom. I'm just gonna do it from the terminal. All right, so let's take a look at this. So this is the shebang. You know what, I'm not gonna go line by line. So how this works is it uses a library called hashlib, which basically allows you to hash within Python. So once again, this is written in Python, and the reason I did that was because I knew Python really well. If you actually wanted to make a program like this, you would not want to use Python. Python is way too slow. These are some global variables I made. So here's what happens if you, this basically explains the usage. This is poorly structured, but this was 2 years ago, so I wasn't that great. This is the error processing program. You can pause at any point and look into this if you want. Basically, this allows me to run error, put in an error code, and then define all the different codes. So pretty long one. Trip checker is something pretty cool that I came up with. Basically, if there's any error throughout the program, like here, it would set trip to a specific number, and then at the end of it, you can run trip checker, and if trip is not equal to 0, it knows there's an error, so it runs the error with the trip, and then of course, it comes up here to actually process that error. Okay, so this right here processes the command line arguments. So this is what processes that, make sure there's no error. So the flag parser basically makes sure that it understands everything given after a flag. So by flag, I mean when I type in hashcracker and then I go like .s or -s. So yeah, that's how that works. And then here we figure out what algorithm we want to use. You have to define that. It's not very advanced. And then here's how it actually works. So basically it has a big while loop, or a big for loop rather, and it loops through the entire supplied word list, and it hashes that, and then it sees if they're equal. If it is, then it says that they're equal. If not, it keeps going, and then if it hits the end, then it says not in word list. Pretty similar, yeah. So it's not all that complicated. It's a little weird. I definitely could have done a better job on it, but let's do a quick demonstration, right? So I'm going to make a really quick word list, and then I'll jump back and I'll show you what that word list is. All right, so I made this word list, and you can see if I type in ls, now it's called test list, and this is the contents. So I just typed in some random stuff. I ended up getting some inspiration on things that I can see from my perspective. But here we have password, hello, 1, 2, 3, 4, 5, 6, and so on. An actual password list would contain a lot more than this. This is just my example. So an actual password list could contain 10 million words. So what this program will do is it'll go through each of these. So say I supply the hash that's sandwich. So it'll go through password, it'll hash it. If it's the same, it prints it. It's not the same though. So it'll continue next one. Is it hello? No, it's not. Is it 1, 2, 3, 4, 5, 6? No, it's not. Is it sandwich? It hashes it. It is sandwich, so it tells me that. So let's actually run this. First thing we want to do is choose the word that we're going to hash. We'll do Python. So we're going to use MD5. So we're going to say Python and then pipe that over to MD5 sum. And this is the hash that we're going to be supplying. So now let's check out the usage. So we give the options, file string, okay. So here's what we have to do. /hashcracker. We have to say -a and then give the algorithm that we're going to use. So we're going to use MD5 and specify the word list. So -w, the word list, which we called it test list. And then -f, which is if we want to use a file containing hashes. This can actually crack multiple hashes, which is pretty cool. But in this case, we're just going to use a string. So -s and then paste that in. And that should be it. So let's run this. It should be pretty quick. Yeah, so it already found it. So you can see it runs through attempt number 1. It says password. Attempt number 2, hello. 1, 2, 3, 4, 5, 6, sandwich. And then it said key found. So algorithm, it gives me MD5. It says right here Python. So that's the actual thing that we hashed. Yeah, so I mean, that's kind of the capabilities of that. We can even do something more complicated. Let's use SHA-256 instead. Instead of Python, let's do keyboard 512. This is a long one, right? So it basically takes longer. It takes longer to crack these. Not only because they're longer, they take a longer amount of time to calculate, but also because they're more exact. So you're not going to have any like false positives, basically, because it is possible. It's just very, very incredibly rare. So let's run this code again. Instead, we're going to use SHA-256, test list, same thing, and then we want to provide the hash again. So we're going to give the long one, press enter, and didn't work. What did I do wrong? I know what I did wrong. I said SHA-256, and we're using SHA-512. So let's fix that. SHA-512, enter, and there we go. Key found, keyboard. So that's kind of the gist of this. It's nothing revolutionary. I just did it because I was learning about how hashes work. So I wanted to try and create a hash cracker and work with that, kind of expand my knowledge a bit. So that's the gist of it. If you want to try it out for yourself, here's the link to my GitHub, and then this is the repository that it's in. Once again, this is only for legal purposes. I'm not responsible in any way for what anybody does with this hash cracker. This is only for educational purposes. That's my disclaimer there. So yeah, I highly encourage that you download it, check it out, mess with it a bit, maybe change the code, see if you can get it to work better or whatever. And let me know if you do actually work with it. I'd love to see what you guys can come up with. So I hope you enjoyed. I plan to do more things like this focused on cybersecurity, more different videos in the future, and we'll see where it takes us, right? So as always, if you have any questions, leave them down below. I'll be sure to get to them. Thank you for watching, and be safe.